All right, everyone. I think now it's 12:40, so I think we are ready to start. Good morning, everyone. It's a pleasure to be here talking with you in NDC Oslo. Unfortunately, this time virtual, so we cannot meet face to face like last year. But I'm pretty sure that by now you are used to having this online events. The topic today is from DevOps to DevSecOps and how establishing a threat modeling process can help you transition. Allow me to just start by introducing myself. For the ones that don't know me, my name is Bruno Amaro Almeida. I'm a principal architect and advisor at Futurize, where I work in different domains such as cloud, DevOps, security, data engineering, and AI. I help companies to either with hands-on projects or all the way to cloud and DevOps strategy. So today, this topic is very dear to me because in my past, I worked 7 years in the cybersecurity industry. So I want to share with you some of the learnings from that time and also how I'm being applying that into our customers. I work for a company called Futurize, which is a digital innovation consultancy, headquartered in Helsinki, Finland, where I'm based, where actually today is very sunny. But we also have offices in Tampere, Stockholm, Oslo, Berlin, London, so across Europe. We are around 600 people and we work with multiple competencies, not just software development, but also with design and advisory. We are a family of companies. Some of them you might have heard, such as Columbia Road, which is an e-commerce and growth hacking company, and also AI, which is an artificial intelligence and machine learning platform. So we do a lot of different projects at Futurize, and in a software development project, it becomes quite common the topic of security, and especially on how can you apply security in your day-to-day. And on a software development team, it can be quite challenging. So first, allow me to start, maybe giving a basic introduction to DevOps and DevSecOps. So when we're talking about DevOps, a lot of people have different interpretations of this. And when we talk about it, I usually like to address it in a way as Amazon addresses it, which is talking about not just about the tooling around DevOps, but also the philosophies and the practices and the cultural of increasing the organization ability to deliver software and deliver value. When we talk about DevSecOps, it's in a way, it's just as an extension to this. It's the same, it's integrating the security practices within the DevOps process. So with DevOps, we are usually talking about having software engineering, operations, security, and quality assurance. DevSecOps is just about the security practices around DevOps. Traditionally is also meant as a security as code. So there's also, of course, as engineers, we know that there's always a focus on the tooling. But today, I want to focus on the process, on the culture that we need to have to establish DevSecOps culture. And in a way, if you think about it, this is the most important aspect today. Because 15 years ago, computing power was expensive. And that's why, like 15 years ago, when computing power was expensive, that we had this bare metal boxes that were increasing insanely expensive and had increasing capacity. We had to find ways as engineers to optimize that computing power, and this is why virtualization happened and was created, because the computing raw power was expensive. And 10 years ago, the storage was the expensive bit. So storing data was incredibly expensive. So that's why when cloud came, the cloud storage was one of the first things that was appealing to engineering and to organization companies, because the cost per gigabyte was quite small. Nowadays, computing power and storage is fairly cheap. So today, the expensive bits are us, humans. The fact that we are here spending our time in a meeting. How we spend our time is the most valuable asset in an organization. It is the most costly item. So DevOps and especially DevSecOps needs to be treated as that we need to enlighten people on how can they enable that security culture, because time is precious and why will they want to do this? So if you think about it, in the past 10 years or so, our roles in engineering changed dramatically. So it used to be that you had a lot of distinct roles across a team. So typically you have a system administrator, maybe a database administrator, a network engineer, a developer, a quality engineer, and all of those individual roles nowadays are being converged into more broad roles. So nowadays, when we talk about a DevOps engineer, we are usually talking someone that has some competences in system administrator, database administration, network engineering. All of those competences now are blended together in the same role. Same as a software engineer. Nowadays, a software engineer role, it's not just about developing code. They need to understand a lot about the software architecture, about the operations aspect. And it's the same thing with security. Traditionally, companies have and that used to be like that 10 years ago, and it's still like that today. But the fact is that nowadays we cannot just simply rely on information security experts to take care of the security on our behalf. It doesn't work that way. And the reason it doesn't work that way is that now the threat is also quite more wide, because now with cloud, we have a lot more power to deploy things as we want and to customize things as we want. When before you maybe had one central team, which was operations, that was providing you the hardware resources or virtual resources. Nowadays, software development teams, DevOps teams are empowered to deploy by themselves. So, of course, from an information security aspect, this is quite challenging. And this is why we, as an engineer, we need to know the fundamentals about security, and we need to step up our game on this. It doesn't mean that everyone nowadays need to become a security expert. But what I advise, and that's the goal of this talk, is that nowadays, because a developer has so many hats, I want with this talk maybe to give you the security hat, maybe meaning that I want to give you a baseline understanding of how can you enable some security practices in your day-to-day, which is threat modeling. So threat modeling is one of the ways to do that, and is not the only thing. And I also, before we jump into the threat modeling, I would like to, to highlight that threat modeling is not the only way to do things, is not the only way to address security in terms of culture, but it is one important methodology that you can use. So right now in a team, this might be the common scenario on the left, that you are still on this mode, that you have a group of specialists and everyone individually is a great specialist. Maybe you have one person in your team that is the expert in cloud, and maybe you have another person who is an expert on network. But the case is that nowadays we are starting to evolve so that everyone needs to have a little bit of an expertise in certain area, but also needs to have a bit of a wider hat. And this is security, hopefully after this talk, will be one of those hats to you. So how engineers typically sell security? During my career, this was something that always bugged me a little bit, because, when we are in development teams, usually we only pay attention to security when something goes wrong. For instance, there's a data breach. Someone hacked our account and some information was exposed. And of course, after that, we are putting all the security cameras around, meaning that after that, of course, we are stepping out on the security. Also, traditionally, you have been getting these bug bounty programs, which are a great way for organizations to, to get from outside, from externals, to get people to report and get some award or some money. some prize based on their behavior of reporting vulnerabilities. But in a way, if you think about it, all of this two ways has been always focused on getting something either to happen or someone external to give us information. Also, traditionally, security audits and penetration testing, like red teaming, is something that appears on this scenario, which is that, you know, as a development team, we are always we might care about security, but we're always waiting for either something to happen or for someone else to tell us what to do. And this can be a bit challenging, right? So if we are always relying on something else to happen or someone to tell us what to do, I mean, there needs to be a better way, right? And this is the problem, is that I see a lot of teams telling me like, hey, Bruno, like, yeah, we care a lot about security, but the problem is that we don't have a location to do that. The problem that we might know that there's some vulnerabilities or there's some things that problematic that we could fix, but we don't know how can we, in a way, convince our management team that this is important and this is crucial. And I wanted to give a bit of an advice here. So instead of thinking on, you know, waiting for something to happen or waiting for a third party person to give that information that you might have a problem, one of the ways that you can have is to, in a way, focus on the business aspects, on the value that is created by enabling a DevSecOps culture. So when you have DevSecOps practices, and threat modeling is just one of them, in your organization, it enables you faster time to market. So if you think about it, all of those things that you will take to document the threat modeling process, it will result in that you have a faster feature delivery because you have a better common understanding across your team, but also the documentation gets up to date, which is really good for things to run a lot smoother, like a well-oiled machine. This also results actually in cost savings and reduced operational costs, because traditionally a lot of companies have this policy that before some critical piece of software is shipped to production, that they need to do a security audit by an external party, which is still very valid. But the problem is that when you don't have this security culture in your team, what happens is that that security audit will give you report to the basic problems that perhaps you could have found by yourself. So the challenge here is that when you are ordering that security audit, you should be already covering the bases. And the threat modeling is one way that you have to cover the bases, which will result in a leaner security audit, meaning that that security audit, when it happens, if you did your homework, will actually have very interesting findings that perhaps you and your team weren't able to find by yourselves, which results in a way in less bugs and vulnerabilities as well. In the end, you get a higher customer engagement and satisfaction, because when you go through the threat modeling process, you and your team will gain a better user experience understanding, meaning that you will actually understand a bit more of the value that your software needs to create. You will understand how people actually will use your software, and you get this common alignment and experience in the team. So the baseline knowledge kind of ramps up quite nicely. And of course, also that when you have security threat modeling workshops in a frequent basis, you also gain a lot of better credibility and perhaps new business opportunities. Because if your system, for instance, needs to comply with GDPR, you probably have to fill a privacy impact assessment. And those privacy impact assessments, one of the things that you should put there is the outcomes of the threat modeling sessions. So for you to become GDPR compliant and to actually have a proper privacy impact assessment that you can share with your customers, the threat modeling outcome will actually enable that. And also if you are trying to become compliant with, let's say, ISO 27, it's a great way to get you to that level in a faster way. because you will do all the homework and you will have all the evidence that you need, that you have been doing the proper security practices. So this is, in a way, perhaps my takeaway on how, from my experience, on how you should try to maybe convince your management team on how to give enough time to have this DevSecOps practices and culture in your team. Now, talking specifically about threat modeling, what is this? So this is not a new thing. So threat modeling has been around for many, many years. It's actually one of the most oldest security practices that you might find. And in a way, is a process to work to identify and commonly understand threats and mitigating those threats. There are different ways to do threat modeling. So the most common ones are the BASCs, the PASTA, Trike, and the STRIDE. So there's different methodologies to do it. It doesn't mean that one is better than the other. There are some of them that might be more suitable for certain cases. But today I would like to introduce you to one which is called STRIDE, which is maybe the most popular, and is also one of my favorites because it's quite it has quite the potential to cover pretty much all the use cases. So STRIDE is an acronym, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So this is all you need to memorize in a way about STRIDE, is that it stands for this. So how does threat modeling work in practice? So going to concrete terms on how can you apply this in your team. So you start with the what you want to threat model, and the what can be a bit challenging for newcomers. So when you are applying threat modeling for the first time, you might feel tempted to apply to everything that you own or your team owns, and it might be a bit challenging because the threat modeling is a process that is kind of an endless process. So even though you have usually 2 to 4 hours in a threat modeling workshop, if you have a very big context, you might feel tempted to go out of those bounds. So when you define the scope of your threat modeling, you should be strict, meaning that, let's say that your team owns an e-commerce platform that has, a front end and a back end. Okay, this can be your scope. But if that e-commerce platform is interacting with a lot of external systems, I mean, you should highlight it, but you should not do the threat modeling on those systems that you don't own. So think also from what your team owns and actually what is their knowledge about that. And that's kind of the best way is to be strict. And the moderator should be, help you to keep the context there. So you start with an architecture or a sequence flow diagram of the system that you want to threat model. And it can be, the scope can be as small or as big as you want, but once again, try to be strict with the scope. So for instance, on this particular example that I was giving of the front end and the back end, you might also want just to threat model the back end or just the front end. So you don't need to take everything in the system. So who should be there? Well, a facilitator, because it's a workshop, and preferably neutral, meaning that you should have someone that ideally that doesn't know much about your system. Maybe you can ask someone from other team to be the facilitator, because of course, as a team, you will be biased towards what to ask and to how to facilitate and what kind of findings you might have. The development team should all be present, as well as the architect, if you have an architect in the team, the product owner. In some cases, you actually might want to invite users or customers, stakeholders. So it's not limited to the team. You shall actually, it's quite beneficial to have in a threat modeling workshop the people that actually use your software in the day-to-day. So having their point of view is really, really nice and gives you a completely different perspective. How this works in practice is that as a workshop, usually 2 to 4 hours, and you should do this, as often as you want, but I usually advise to 3 to 6 months, because if you do it too often, you will not have time to fix what you find, and if you do it also too spaced, things already change too much. So ideally, I would say once a quarter or once a semester, it's the ideal timeline to do a threat modeling workshop. You can do this also, like, I think it's important, and a lot of people ask me this, like, when should I actually start if I maybe don't even have a single line of coding in that? Maybe it's a new system that we are just thinking about it. And this is fine. I think as soon as you have an architecture that can be shared and commented across the team, you can do the threat modeling session. So you don't necessarily need to have a full developed system, a full mature and production ready system. So you can do it quite early in the development cycle. And in a way, the workshop, you are going to iterate over the stride, meaning that for each of the stride terms, you are going to put yourself and the rest of the team in the attack queues, and you are going to exhaust that term before moving to the next one. So we are going for all what stride stands for. You're going to cover one by one from an attacker perspective. And the typical outcome of this throughout the workshop is that you are going to have, well, possibly architecture changes, things that you and the team decide, like, well, now we need to, based on this, we probably need to change this or enable that piece. You might have to increase security measures, security policies might need to be rethought. And of course, there might be items that you and the team might not be comfortable, meaning that you might not know actually at that point. So you might mark them as things that you need to investigate further. So there's multiple, in a way, potential outcomes from this. I wanted to give you one very basic example. So, you know, if you have like this, maybe this is the most popular type of architecture that you will see in tech, which is that you might have a website that has a database, and it might be as simple as that you have mobile and web clients interacting with websites. So your architecture might be that you have, well, might have a web server with a relational database connected to it, and in a way you might have something like it being providing some kind of dashboard with some metrics. So taking this, I would like to, you know, I invite you to do a small threat modeling with me during this session. Of course, we don't have 2 to 4 hours, but so I'm going to just go, I'm going to put myself in the role of a moderator, and I will throw the questions that the moderator will potentially do around this type of scenario. So once you have this architecture drawn on the board, we start with the first term of the stride, which is spoofing. And spoofing is, in essence, to pretend to be something or someone you are not. So in this particular scenario that we have the web server with the dashboard, one of the questions that the moderator might do is that, how do you authenticate the user or the service? So, you know, you have mobile and web clients interacting with it. How are the authentication being handled? And how can you actually authorize and validate that person? Meaning that, is there a way as an attacker that I can, in a way, go to the website and log in without or be authenticated with actually having the proper credentials? There's a lot of ways on how this could happen, but it might be that you don't have for instance, a proper security mechanism. Maybe you have very simple passwords that can be brute forced. Things that you might think is that, well, yeah, it is possible that someone will brute force because we don't have very complex requirements for the passwords, or we don't even have this like a multi-factor authentication to authorize and validate users. So, you know, one outcome from this part will be that, well, I think that, you know, to avoid having someone to increase or to step up our security game, we should enable multi-factor authentication in the service. It will also be that it's not just about an anonymous user becoming authenticated. It might be like, how, if I'm a valid user that just registered, can I somehow pretend to be user B? So can I maybe change something in the URL and all of a sudden I'm logged in as a different user? So can I do that? So trying also to understand like this lateral movements, I think is also super important. And also on authentication and on the spoofing, you can also think about on the entire architecture. It's not just about the mobile and web clients. You can also think like, you as a developer, can you as a developer log in to the web server using your, let's say, SSH credentials, and can you actually impersonate your colleague? And if you can, will that be caught in an audit trail? So can you, in a way, pretend to be your colleague Mike and do something on his behalf, pretending that you are him? So also thinking from this perspective. Then when we exhaust that term, we will go to the next term, which is tampering. And tampering is to manipulate or change information that you are not supposed to, which seems kind of obvious, right? But let's taking that example that if I can impersonate Mike, can I change his password? Can I change his access, or can I delete his files or his information? Can I go around the business control logic? So, if you are an attacker, why, instead of trying to log into the web server, maybe you are trying to attack the database. Maybe your database is exposed to the internet. So is there a way that an attacker can actually go and connect directly to the database? Maybe you have, for instance, a bastion host that is overly exposed to the internet and has direct connection to the database. So, try to think as a team, try to think on all the bad things, that could happen, and how could you, implement mechanisms to prevent that. So for instance, that if you have a database that is directly exposed with an endpoint to the internet, maybe you want to move it to a private space. You want to maybe have a security group around it that only allows the web server to connect to it and not anything else. So those are the typical actions that you might generate from this. When you exhaust tampering, you can go to the third term, which is repudiation. And repudiation is the ability to claim you didn't do certain actions, no matter if you did it or not. And this is one of my favorite ones, because what happens is that if you are using a system, you might have a situation that you might get in legal trouble, because let's say that one of your customers logged into the website and purchased 10,000 items, and you paid it. And then you will maybe say that, maybe you will you will claim to you that, well, I actually didn't. It was not me. Someone ordered this on my behalf. Maybe your system was attacked. And here the question is that how can you prove that that customer actually performed that action? So if you are, if you go to court, how do you have an audit trail that can actually say, in a very formal and concrete way that, yes, this user logged in to the website from this IP address, and he, at this particular time, from this particular geographical location, and he performed all of these actions. And if needed, can you actually retrace those steps? So, can you actually tell, like, yes, first you went to this part of the website, then you used, then you purchased, you pressed the button 10 times or 10,000 times, if you will, or you change something like this way. So can you actually, do you have an ability to do this? So how can you actually implement this? Well, different ways, but there's, for instance, if you're using cloud, you have, let's say that you are using AWS, you could use, for instance, CloudTrail to log in the API calls, to have the audit trail of the API calls that happen in the account. You might enable, for instance, VPC flow logs that will, in a way, audit the network traffic that happen in the account. You might also, of course, implement your own business logic to store, to log these actions and store it somewhere safe. So in a way, repudiation is super important because it's one of the most, it's kind of the single source of truth, if you will, on how you have to prove that someone did or didn't do certain actions. So taking even the case that I was mentioned, that the user claimed that maybe your website was attacked. Well, maybe your website was attacked. If you have a strong audit trail, and the audit trail didn't pick that action, maybe it picked from an unauthorized user, maybe that audit trail will help you to also dig deep on what actually happened and retrace what went wrong. So this is super important as an aspect that you need to consider. And also, other term of stride is information disclosure. And information disclosure is to leak or to expose information. And this nowadays is one of the most popular, for the wrong reasons, aspect that happens in information security. And people need to really step up their game on information disclosure, not because, of course, can be a PR disaster, but also because you need to understand when you are developing a software what information is actually sensitive. So, for instance, if you are handling personal information, you need to really understand, like, am I collecting and am I storing the information that I really need, or am I storing information that perhaps I don't need for anything, it is never used. So am I, in a way, can I actually ditch some of the information that I'm requesting and storing? Can I be more lean about that? And also, like, understanding what are the risks of unauthorized information exposure to the public. So taking, for instance, the database, think about, like, what will be the consequences of, let's say, a full dump of your relational database being exposed in the internet. What actually will happen? What information is there, and what is actually encrypted on that database? And perhaps that's one action that you might want to do, is that, well, I want to enable, like, row-level encryption. So if there's a dump being exposed, at least certain parts that are very sensitive were not exposed because they don't have the encryption keys. But think about all the possible scenarios on what can go wrong and why. And also, not just about information being leaked in the internet, but also, like, what will be the consequences of other users within that system to see the information of each other. So, for instance, if you have financial, like, let's say that you are working in banking, maybe the most evident example will be, like, well, you have access to your bank account and your bank account transactions, but what will happen if you could access and see the information of someone else within that system? So I'm pretty sure that you'll have a bad time as a bank to explain that, how your bank account statements were in a way shown to someone else. So think also from this perspective, is like any kind of leak or exposure of information. Now, a denial of service. So, denial of service is to prevent the system to provide a service. And this is a very common, still common type of attack. Is, we see that across the globe, you are getting bombarded with requests from a malicious attacker that are enabling your valid customers to access that website. So thinking about what you need to think about here as a team is that, well, what is the service that the system is providing, and what are the consequences of having 10 minutes downtime, 1 hour downtime, 1 day downtime? What if no one can access that website? What are the consequences of the service that you are providing to be interrupted, and how likely it is to happen? So, like, did you have any past experiences with that? Is there anything that you can change in your architecture to do that? For instance, if you are using a web, if you have a web application, like in the example that we demonstrated, can you enable a web application firewall? Can you enable, for instance, some kind of, let's say that you are using AWS as an example again, but let's say that you could enable a CDN with like CloudFront with Shield that will, in a way, prevent this type of attacks and will at least mitigate them. So thinking about what kind of changes could you actually have to your system to prevent and mitigate this type of attacks. Now, the last term is elevation of privilege. And it's best known for the gaining rights to the things that you are not supposed to. So think here on how can a user escalate to gain admin rights. So, right, if you have, if the users that authenticate to your system have different roles, maybe you and your team have this administrator role, and your customers have a viewer role or an editor role or whatever you want to call it, is there a way that those users can escalate themselves to administrator? So can they change something in the URL? Can the database be, can a database be attacked? Can like an SQL injection that will change something in the role of the person, and the person automatically gains admin access? So other example is that, can a user with an expired subscription continue to use the service? So for instance, if you are billing your customers monthly to use your web application, what happens actually when that subscription expires? Can they still log in? What they will see when they log in? Will they be able to access services that they were not supposed to, even though their subscription is not valid? So these are things that you can think on, really think about the business case and how what makes sense and what kind of controls you have around it. And I think that's the most important things that you need to think in elevation of privilege. When this might sound very, in a way, heavy process, but the good news is that there's ways to make this more fun. So if you want to run threat modeling sessions, you might want to explore security games. There are plenty of security games, not just about threat modeling, but in general, there's for multiple reasons, multiple topics. But in threat modeling, you have a game called Elevation of Privilege, which actually was open sourced by Microsoft. So it's a card game, and you can have those cards printed, and those cards will have, in a way, some of these questions that you might make around each term of stride. And it's a really cool way that, when you don't know much, like when you don't have the experience as a moderator to make the questions, this card game might give you some good hints into the team, make it like fun, that you don't need to think it too much on what questions to make. So definitely something that I will advise you to explore. I run this in a couple of threat modelings in different projects with the card game, and it was really cool in a way that it made other people interested in being moderators because it was so kind of interactive. So definitely something for you to explore. So it's also like very important to think, in essence, like what is actually the value that you create with this? When threat modeling, it's a bit time consuming when you think about 2 to 4 hours, but if you do it like every 3 months or every 6 months, is not that much time. But what will happen is that the outcome of the threat modeling will be quite heavy, because you will end up, you will have a security backlog, let's call it like that. You will have actions that you either need to, things that you need to change in your system, or you have things that you need to investigate. So you are going to uncover new work. And I don't, even though I call it security backlog, I don't like to, it's actually like a bad term, because in a way, these actions should and will be part of your common backlog, and you will need to prioritize them. Think about how likely it is to happen, how urgent, what are the benefits that you will give to the users, the immediate benefits. So always, it's good to have this type of guiding principle on how to prioritize that backlog. One of the things that you'll create as a value of this 3 hours or 4 hours of threat modeling is that you'll have an architecture and flow diagrams up to date, meaning that I know based on my experience that is sometimes very hard to keep documentation up to date. It's kind of the last thing that we do, and it can be very challenging to try to have this kind of like common alignment in terms of what is our architecture, because things might change very rapidly, and especially like every 6 months, definitely things change. So one of the unintended consequences of having a threat modeling workshop is that you will gain, because you are going to draw it and you are going the architecture, and you're going to be accurate about it, because everyone in the team will say, well, this actually changed last week, now it's like this, or vice versa. So you actually gain this kind of common knowledge, and you have these diagrams can be up to date, even The simple fact that you are able to take a picture from that whiteboard and you get up-to-date diagram is quite beneficial. The other is in terms of security and compliance. I mentioned this a bit earlier, but in a way, if your organization wants to implement, some GDPR program and they want to create this privacy impact assessments, the outcome of this threat modeling is something that you can link to it, and it will benefit greatly. The other is, of course, like if you want to be compliant, if you want to meet the requirements for PCI DSS, which is the payment card industry, or ISO 27 or any other program, having this threat modeling process helps a lot, because it's a lot of the homework that you will need to do as a team to meet those requirements. Also, of course, the alignment within the team. It can be that when you have a team of 5-10 people, everyone will, in a way, work on kind of independent things towards the same goals, of course, but it can be, it's very hard to find that time to create this kind of alignment. And the threat modeling workshop actually works great, because you have the PO is also there, maybe some users are also there, and you gain a lot more visibility on actually why you are doing what you are doing in the day-to-day. And I think that this is one of the kind of like indirect values that comes from the threat modeling that I would like to highlight. So, in a nutshell, if you want to implement Stride, you need to recap those terms: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And if you have that as a cheat sheet, it's kind of super easy then to iterate over that. So I'm hoping that you found this valuable and interesting, and I will be happy to answer any questions if you have now, or feel free to reach out in Twitter or LinkedIn at any time. And yeah, thank you so much.